Electricity consumption optimization using K-means clustering algorithm. Henry 2017 710116. Advisor Dr. Dong Yushin President. Co-advisor Dr. Nawab Muhammad Fresh Kirsch, Soonghan University, South Korea. Outline, introduction, related work, proposed approach, analysis of electricity consumption at home through a theoretical perspective, analysis of electricity consumption at home using K-means clustering algorithm, evaluation, electricity consumption at home analysis, K-means clustering analysis, conclusion, and references. Introduction continues. Backend, component, dataset for consumption use turbine. So main techniques that solve the optimization problem of electricity, but none of them focus on housing electricity optimization. Housing electricity optimization. Reducing the cost, factor of overcharge, prediction are not available. Introduction continues. Solution. K-means algorithm. Why choose K-means cluster? Predict the answer from the dataset. No any answer is available in terms of K-means. Why predict the answers? No clear result. In this paper, electricity usage of home is analyzed through K-means clustering algorithm for obtaining the optimal home usage. Electricity usage of home is 3A is analyzed through K-means clustering algorithm for obtaining the optimal home usage electricity data point, the current garbage index, Davis burden index, and serial score find detailed optimal number of clusters in the K-means algorithm and present the application scenario of the machine learning algorithm. 3B is reducing the A per 1 dataset and the result the same result. The proposed approach delivers us efficient and meaning prediction result never obtained before. Related work, machine learning. A way to run machine with dataset values, reference 1. Several ways such as reference 2 and 3 and 4. K-means clustering, one of the methods for the machine learning algorithm under the unsupervised learning category. Reference 5. It is a main task of exploratory data mining and common technique for statistical analysis used in many fields. Reference 6, 7, and 8. Community feasibility assessment. Cluster analysis is not one specific algorithm. What constitutes a cluster and how to efficiently find them. Popular notion of clusters include groups with small distances between cluster members, dense areas of data spaces, reference 9 and 10 and 11. Related work continues. Classification is a process related to categorization, the process in which ideas and objects are recognized, differentiated, and understood. Reference 12, 13, and 14. Supervised learning. Supervised learning is the machine learning task of running a function that maps an input to an output basis on example input-output pairs. It infers a function from leveraged training data consisting of a set of training examples. Number 15, 16, and 17 references. Unsupervised learning. Too many approaches to solve the problem, such as in clustering, K-means mixture models, DB-scan, optics algorithm, reference 18, 19, and 20. Index. From the unsupervised learning need how to efficiently find them. Popular notion of clusters include a group with small distances between the cluster members, dense areas of data space, such as current garbage index, serial score, Davis burden is reference 21. Related work continues. Scikit-learn, one of the machine learning library from the 2007 till 2019 continuous update the version of the library, number 22. This is the machine learning repository overview, and then I use the use Turbine machine learning repository individual household electric power consumption dataset. This is reference 23. Count dataset parameters. Number 1, date. Date in format, day, month, year. Second, time. Time in format, hour, month, minutes, second. Number 3, global active power. Household global minute average active power in kilowatt. Number 4, global reactive power. Household global minute average reactive power in kilowatt. Number 5, voltage. Minute average voltage in volt. Number 6, global intensity. Household global minute average current intensity in ampere. Number 7, submetering. 1. Energy submetering number 1. in watt-hour of active energy. In correspond to the kitchen containing mainly a dishwasher, an oven, and a microwave, hot plates are not electric but gas-powered. Number 8. Submetering. Energy submetering. Number 2. In watt-hour of active energy. In correspond to the laundry room, containing a washing machine, tumbler dryer, a refrigerator, and a light. Number 9. Submetering. 3. Energy submetering. Number 3. In watt-hour of active energy. In correspond to an electric water heater and an air conditioner. Definition of dataset. Household power consumption from dataset downloaded from the UC California Urban Machine Learning Dataset Repository, reference A, and then use it. This dataset is via delimiter is divided. Global active power, global reactive power, voltage, global intensity is divided. Global active power and global reactive power, y-axis experimented. Proposed approach A. Analysis of electricity consumption at home through a Shiller score perspective. Shiller score is an easy way to data I each data cluster in data's definition and I each data is not clustered inner and data's definition. BI Shiller score SI is equal to calculate that SI equal max AI PI minus AI. From this calculate, SI is equal to the function minus 1 SI 1. Si is the close to 1 is the data, I is the correct cluster to each thing. Close to minus 1 cannot distribute cluster is distributed. From this paper, machine using the machine learning library scikit-learn in household power consumption clustering. Reference 23, 24, and 25. Analysis of electricity consumption at home through a Shiller score perspective continues. Currency-Karlov index. How to be where to be clustering. In a way is Currency-Karlov index, Davis-Burdon index, Dunn index, Shiller score. In this paper, evaluated via Currency-Karlov index, Shiller score evaluated. From the cluster Currency-Karlov index, the cluster's distributed average and cluster distributed ratio will give it to you. Sk equal TRWK, TRBK. K minus 1 and minus K. For this BK is distributed matrix from the each group. WK is the cluster distributed defined. Numbers 26, 27, and 28. WK sigma Q equal 1K X CQ and X minus CQ and X minus CQ and T. BK sigma Q and NQ and CQ minus C and CQ minus C and T. Analysis of electricity consumption at home through a Shiller score perspective continues. Davis-Burdon index. If the ground truth labels are not known, the Davis-Burdon index scikit-learn matrix Davis-Burdon Rij Si plus Sj Tij, then the Davis-Burdon index is defined as dB equal 1 K. Sigma I 1K max I not J. Rij, the 0 is the lowest score of possible. Score value closer to 0 indicate a better partition. But the problem is this algorithm do not attach it in the scikit-learn library and only explain it in the document page but cannot export easily. Number 29 and 13 and 31. Proposed approach B. Analysis of electricity consumption at home using K-means clustering algorithm. Reducing dataset. A per 1 dataset for this archive contains 207, 5,007, 259 measurements together in house located in Secus, 7 km of Paris, France, between December 26 and November 2010, 47 months. Note, this is the same result, labeled data for machine learning, already clearly cleansing for the dataset. Evaluation, declaration, and resources. TSMPC configuration software. First paper execution snapshot. Second paper execution snapshot. Analysis A. From K-means algorithm, calculate the proper cluster seen is very important. From the data estimated Shiller score, the result is K equals 7. Each cluster centroid and data prices Shiller score are 0.799 is the optimal score. From the former Currency-Karlov index, results are 516.3999 is optimal result. Using this K-means algorithm, the fact is here. Analysis A continues. But the problem is algorithms do not attach it in the scikit-learn library and only explained in the document page but cannot exploit easily. Analysis B. N-cluster variance explained vs K. N-clusters variance experienced vs K. Figure Shiller score according to change of a cluster number. Figure A per 1 dataset Shiller score according to change of cluster number. From K-means algorithm, calculate proper cluster seen is very important. From the data estimated Shiller score, The result is k equals 7. Each cluster centroid and data prices serial score 0.799 is the optimal score. Even if data set is so small, but the A1 data set k equals 7, each cluster centroid and data prices serial score 0.810 is the optimal score. From this K-means algorithm, cluster 7s, all the dataset A1 dataset, each group's centroid and each centroid distance will be an optimal value. From this result, the dataset decreases, but the K-means cluster in class vector spaces. Its optimal cluster is the same situation with before original dataset household power consumption rate via clustering. Evaluation A execution snapshot k equal 2, k equal 3, k equal 4, k equal 5, k equal 6, and 7, 8, 9, 10. The k equal 7's result is optimal result for this experiment. Evaluation B execution snapshot A for 1 dataset k equal 1, A for 1 dataset k equal 2, A for 1 dataset k equal 3, A for 1 dataset k equal 4 and 5 and 6 and 7s, 8s and 9s and 10s and 11s. This is also A for 1 dataset k equals 7 is the optimal result for this experiment. Software and workstation environment. PC performance. Software Anaconda 3 plus PyCharm 3. Web software Windows 10 Professional. RAM 16GB. Processor i7 6600U. CPU 2.0 16 GHz. Hard disk 420GB SSD. System PC configuration software. Dataset used turbine machine learning dataset. Scikit-learn Anaconda 3 PyCharm. Scikit-learn Stable Anaconda.com and JetBrains and then PyCharm. Options personally can easily follow it, and because using the BSD license to real world don't have difficulties to do that. Conclusion: household power consumption via K-means clustering uses the library which is Scikit-learn Anaconda 3 open source personally can easily follow it. And because using BSD license to real world don't have difficulties to do that. Not only the K-means algorithm, PCA algorithm, but also SVM algorithm, etc. Other machine learning algorithm cluster can also do it. From this result, in real life, household power consumptions, diverse analytics, and electric transformer transmission power management period can estimate it. And each data using electric consumption, it can be used for the progressive taxation, regional to regional demand forecasting, maintenance of power plant and facilities can do it. In the gas company, Seoul Gas and Google TensorFlow meter of second 2017 and can estimate via K-means algorithms and also can estimate about the gas consumption rate to via K-means clustering and index. Published paper, Hyunwoo and Nawal Mohammad Fakish and Dong Yoshin. Comparative analysis of electricity consumption at home through serial score perspective. ICHCT 2019, South Korea. 2019, Sungwon University, Korea. Hyunwoo and Nawal Mohammad Fakish and Dong Yoshin. Analysis of electricity consumption at home using K-means clustering algorithm. ICHCT 2019, South Korea. 2019, Sungwon University, Korea. Acknowledgement, Advisor, Dr. Dong Yoshin, President of Sungwon University, currently May 14, 2019. Co-advisor, Dr. Mohammad Karashi, Assistant Professor. First joined the SKKU Mobile Computing Laboratory, Professor Hyung-yun as SKKU Fellow. Advising for pre-defense, Dr. Narratics Excellent Professor. First joined the Open Lab, Dr. Chun Sung-na. POSCO ENC and Hyun Seok-chun and Duty Manager. Corporate Partner, LG Electronics and LG CNS and NG Plus. Myung-sun MD PhD. Google TensorFlow Meetup Second 2017 conference from Seoul Gas, OpenLab member, currently May 14, 2019, Dr. OpenLab member, Dr. Gi-young Choi and Muhammad Hamza and Janet and Woo-young Kim and So-chung. Acknowledgement, academic tuition and education and education and NG Plus invited the conference and participate the feedback for the researches and transportation support from the POSCO ENC, the duty manager from Hyun Seok-chun. Google A motivation from the conference, TensorFlow 2017. Korean Air supported the Monicom service at participating in conference. Incheon International Airport safe security and relaxation time. Release stress and volunteer works. And the Assam Medical Center. Region management and the Samsung Eye Center. Spirit support from the Myungji Hospital. References. This is the final result for the references. 20 and 13 and 37. This is the end of the slide. And waiting for the